topic will start. I hope uh, all of you are able to hear me, right?
Yes, can hear.
So today's topic is mainly I am going to cover. I am going to cover today mainly is non-normal data. How to handle non-normal data, right? Process capability of non-normal data. That's what is agenda today. Okay, I'm going to cover that how to transform a non-normal data into a normal data, and how to do Johnson transformation, how to do Box-Cox transformation, and by doing that, how to arrive process capability CP/CPK, right? So just I wanted to know before that, all of you know what is the normal data or what is process capability of a normal data. Anybody knows? Then only we can go think about non-normal data. Anyone? Because this generally we are covering in black belt. This normal data distribution and normality test. Then CP, CPK, PP, PPK, all those things. Generally we are covering in uh, black belt. Okay. So can anyone just give a throw a light? What is capability CP, CPK? What is the purpose of that? And what is normality test? Anyone knows? Or we will have a small discussion on that, then we'll switch over to non-normal. Can anyone say? Give some, whatever you know, just tell, then we'll discuss further. Anybody in the team?
I think it will be better if you can give some quick overview on that and then start. I think we have known that, we have studied it, but it is better refreshing it and then taking it forward on that.
Okay. So, CP, CPK also nobody heard. Can anyone give in chat box? If you know CPK, just say thumbs up in the chat box.
But
Yes,
it is
CPK.
normally expected that all of you know the basic capability analysis, CP/CPK study, so that we can talk at the next level. Like if data is not normal, how can we conduct the capability analysis?
Talking about discrete data and continuous data.
We are talking about continuous data today, right? Continuous data is nothing but there is a decimal available and there is some units available like millimeter, all those things, right? Millimeter or any unit, temperature. Then we are talking degree, weight means kilogram. Okay, those kind of data we are calling as continuous data, right? Okay, CP/CPK generally we are when we are talking in terms of continuous data, right? Okay. So only I think one person has said a thumbs up. Okay, so I'll just get CP/CPK just process table for short term and PPPK for long term. Good, very good, right? Okay, so CP/CPK generally we are doing for capability of a process. Okay, so how do we know process is capable or not?
Lesser deviation, less variation.
Less variation with reference to
Control
reference to the optimal value.
no.
The specification, reference to the specification.
Very good, very good. Okay. See, CP/CPK is we generally talking as a process capability, right? Now, what is process capability? What is the capability of a process with reference to what? With reference to some specification, right? Who is giving the specification? Generally, who gives the specification?
Customer.
Customer gives us the specification or our designer. Okay. If you are responsible for your own design of your product, then designer will give the specification or customer will give the specification. Okay, so we have got a process variation. So what is the process variation? Generally we call it as in terms of control charts or upper control limit or lower control limit, right? So with reference to your upper control limit and lower control limit, how much you are inside the specification limit. So this is actually we are calling it as capability. Okay, a capable process is a process where your control limits or your process variation. Process variation is what? If you make 100 parts, 100 parts will not be of the same dimension, right? There will be a variation, right? Piece to piece, there will be a variation, okay? But this variation, how much it is allowed, right? So whether you are meeting the customer requirement with your current variation, right? If you are able to meet that your variation with reference to control specification limits, then we call it as a capable process, right? If it is out of specification, we call it as not capable process, right? So that is ultimately we are talking about CPCPK, right? CPCPK generally is done for somebody was mentioning here. It is for short term, right? And PPPK is called, but typically called as process performance, right? So process performance we are generally considering for a long term. Okay, what is the difference between major difference between CPCPK and PPPK? One
PPK
is
is a
perform
long-term process.
long term,
And
otherwise short term.
CPK
So
is
what
for
is the difference? Very good. But then what is the difference? How you are differing?
CPK,
The
we
way
can
which
take data in a same
huh?
shift.
Uh,
In a same day, how many shift, all these things. PPK is we have to take for 6 months data and analyze. Do the
see,
capabilities.
yeah, you are right. So basically, we are the way which we calculate the standard deviation. There is a difference, right? So standard deviation is a measure of variation. Okay, measures of dispersion. Okay, so with the way which we calculate the standard deviation, right? That is the where it is differing, right? Now in CPCPK we are considering the data in terms of R bar by D2. The standard deviation we are calculating R bar by D2. Whereas PPPK, what is the formula? Anybody knows? What is the formula for the standard deviation? X bar minus xi whole square divided by n, square root of xi minus x bar whole square divided by n minus 1. That is the what is the standard deviation we are using in PPPK. Whereas in CPCPK we are calculating R bar by D2. Okay, we calculate the range of different subgroups, and we take subgroup means at a time how many time parts we are taking. So let us say today 7 o'clock we are taking 5 parts. 8 o'clock is 5 parts. 9 o'clock 5 parts. So we calculate the range of that, and we calculate the total range R bar of uh, range divided by the standard constant which is called statistical constant which is called D2. So R bar by D2 is generally the standard deviation formula. Whereas in PPK, different formula we are using, right? Okay. And CPCPK generally when we consider, we don't consider the unstable points. Unstable points is out of control points, right? Auto control points we generally don't take in CPCP because it's a short term. It's a capability we are considering. So we don't consider the auto control points. Whereas in PPPK, we don't no, eliminate any points. We are taking all the points in the data, right? So these are all the some of the basics of CPCP and PPPK. And one more point is that the data should be normal. Okay, now what do you mean by data is normal? What is
Normal
the
Variation, common
hmm?
variation.
It's a variation due to common causes, right? Okay,
Common
so
cause.
common causes. Okay, so that kind of data. Now, what will be the shape of the distribution when you are making a normal data? What will be the shape
Bell
of the
curve.
distribution? Hmm?
Bell
Bell
curve.
curve. Okay, what is the particular? What is the speciality of bell curve?
This normally distributed, data
Uh,
normally distributed.
Distributed. It is a symmetrical. Okay, the right side of the data and the left side of the data, it is symmetrical. What is symmetry? Either right side or left side. It is equal, right? So this is what we call it as a normal data. Okay. So when we calculate a CPCPK, we generally assume that the data is normal, right? Now here we are talking about non-normal data. So it is obvious that the data is not normal, or the data is not normally distributed, right? So that is the that kind of data. When we are so life is not very simple. Okay, sometime when we get a collected data, this data not necessary that it will be a normal, or it will not follow a normal distribution. Okay, so in that case, what we have to do? We may have to do some kind of transformation. So what kind of transformation we'll do? We do a transformation in such a way that a non-normal data becomes a normal, right? A non-normal data will become a normal, right? Okay. So this is what is we are going to discuss. So it's an advanced version of normal distribution. So here today we are going to discuss about a topic where when we come across a data which is not normally distributed, how we can transform this into a normal distribution, right? Okay, so that is the agenda of today's class, right? So I hope everybody is clear with the recap. I think everybody is clear, right? Okay. So now I just wanted to know that all of you are conversant with Minitab. So we are going today, whatever we are going to discuss, we are going to, oh yeah, some of you are conversant, right? Maybe some of you, what you can do is that if you have got a Minitab available with you, I will just put one data in chat box. You can open that. Okay, I'll just put one data in chat box. Okay, and someone can if someone can open that, we can share it to the screen so that I can teach you through the this one. Or if you want me to do, I'll also do that, right? Okay, 1 second, I'll just share one data. uh, 1 second, I'll just data is open. I have to close it, right? And sharing one data. Can anyone confirm that that Excel sheet I shared is you have received? It is put it in the chat box. Yeah, received. Okay. Now we will have a small discussion. Then when I am telling you to open, that time only you open it. Then if you can open the mini tab also, we can and you can share. I'll tell you how to do that, right? Or if you want me to show, I'll also show you, right? Okay. Right. Okay. So I'm sharing my screen now. Anybody has any question on normal or normality data or any question you can ask me. Otherwise, we'll straight away switch over to the topic. Right? Screen is visible to everybody?
Yes.
Okay, fine. Okay, so process capability of non-normal data, right? So today what we are going to discuss, already I told that what is why we need normal data and how to test normality and how we transform a continuous data and make it normal. And there are two kind of transformation we are going to discuss, which is very popular. One is called the Box-Cox transformation. Another one is called the Johnson transformation, right? And using that, we can see that what is the result, right? So this is what is the topic we are going to cover, right? Okay, everyone is okay.
Okay.
Okay,
Yeah.
sir.
Okay. So already we said why data is what is the purpose of normal data, right? The purpose, the normal data is a data where the data is distributed in a symmetrical way. Okay, now this data you are finding on the screen, is it symmetrical or it is you are finding some skewness in this? This is the histogram time taken to send a file to Bill, right? So what is the speciality of this data? What is the what you are finding here? Can anyone say? What you are finding here? Is it positively skewed or negatively skewed? I think it is written here.
So it is positively skewed.
Positively skewed. If the long tail available this side, it is called positively skewed data, right? A normal distribution will be something like this, right? Okay. A normal distribution generally will be something like this. You will find like this, right? This is the normal distribution. Okay. So that either this side or this side, it will be symmetrical, right? Okay. So this data typically what we are seeing is that there is no symmetricity, right? All of you are agree? Yes.
Yes.
Right.
Yes.
Okay. Yeah.
Yes, sir.
So this is called typically positively skewed data. So what is the meaning of this data? What you are finding here positively skewed, right? This means see the time taken to send a file to bill. So you can see that so many bills are during this time it has come here. Okay, but many data is coming very late. Okay, if it is a symmetrical means either right side or left side it will be same. But here you can find that many bills are have received they received in this time. Okay, and only few data is like this. Okay, you can find this kind of situation where generally if you take a salary, okay, you can find that our top management salary will be very high. Okay, top management means director, those kind of people, or few people's salary will be very high, and other people's salary will be like this, right? Okay, so it will be something like this, right? Okay, this is kind of typically called positively skewed data. Or in a running race, you are see, typically you are 100-meter, 200-meter race, running race. You can find that many people are running and reach the point in more or less the same time, but some guys will be there on the running in the late. Okay, I mean they will be very slow and they will be on the backside. Okay, few people, many people will find cross near to the finishing point, they will be together, right? Something like that. Or you can see in or in a traffic jam you will find that so many vehicles are at one time and many vehicles are on the rear side. Okay, something like this. Okay, like, can you give some example of negatively skewed data? Anyone can say? Negatively skewed is what? How will you the negatively skewed?
If they
Negatively
run
skewed.
very quickly, if they run very quickly, then they have completed within very less
Yeah, yeah.
time. It will
This
be
time.
negative.
Many people are there on that finishing line, right? Negatively skewed, can anyone see some example? Negatively skewed is what? It will be like this. Okay, many people are here and many people are coming here. Okay, so it will be just opposite of this one. Can anyone say any example of um, negatively skewed data? Anyone knows?
Retirement age data.
Ah, retirement age. Okay, good example. Okay, you mean to say many people are there on the retirement age and few people are on the entry side? That's what you are meaning?
Yeah,
Uh,
absolutely.
okay. Many companies, this all the TVS company and only will be finding like this. Okay, many people are there on the retirement age, 50 plus. Few people are on the return. Okay, or you can say, yeah, very close to that. You can say that these companies, generally in organizations, you will find that many people who stay, they'll stay for a long time. Okay, and few people are there who will be quitting very quickly. Maybe 1 year, 2 year, they will be jumping or to new opportunities. And some people are there who are attached to the organization. They will be there for a long time. Okay, especially this lower level. That means in associates and all. You will find that many people are leaving on the in the early stage, but some people who stayed, they will stay for a long time. Okay, so that kind of situation generally comes in the negatively skewed data, right? Okay, so this is typically called negatively skewed data, right? Okay, so some example like this, right? So here today we will be discussing some data related to this, and we will see that how we can transform this, right? Okay, so this is clear. Okay, positive and negative skewed, all of you are clear now. So it is not symmetrical generally. Yes, okay, fine. You can just put a thumbs up whenever I am asking some question, so that it will be more like an interaction. Otherwise, it will look like monologue. It should be a dialogue. Okay. MBB, we are not learning. Actually, we are mutual learning. MBB, right? Okay. Here more discussions than monologue, right? So all of you are clear, right? Okay. So this is typically called non-normal data, and next, what are all the consequences of non-normal data? If data is not normal, what will happen? See,
It
what
may
will
be
be
positive
the
or negative, sir. It may be positive or negative based on the process. Sometimes
so what is
it is a positive impact or sometimes it is negative.
negative? That's okay. But what is the consequences? Consequences if the data is not normal, what will happen?
Variation may out of control limit. Variation may occur out of control limit over the period.
Okay. Another thing is that, see, when whatever we call it as generally, what is the one sigma? How many? If it is a normal data, just imagine this is a normal data, right? This curve. Okay, what will be the distribution? Like, what will be how many percentage will be within one sigma limit? If it is a normal data, how many points on one sigma limit? Typically, how many points will be there on one sigma limit? Let us say this is a normal distribution, and there is a line like this, and we have got sigma limits, right? So how many points will be there in one sigma limit? How many points covered in two sigma limit? How many points are covered in three sigma limit? Anybody knows?
So
1 sigma
1.2 to
68.
1.6.
No. Percentage of covering. Percentage. This area. This is one sigma limit. What is the coverage?
68%.
68%. Right. So 34 on the right side and 34 on the left side. Okay. Now what is the condition of two sigma limit? How many points will be there in two sigma limit? Total. How many percentage?
26. 26.
No, this is put together 68. What will be the, if you cover
32.
no,
Something
it
around
is
80 to 86.
no 95.4. 95.4 percentage is on the both side. Okay, one sigma limit means both side put together it is 68% of the distribution is covered in one sigma limit. 95.4 percentage is covered in two sigma limit. And how many points on three sigma limit?
99.73.
99.7. Now you are gone to the point, right? Okay, 99.73 is on the three sigma limit, right? Okay. Now, since this is not a normal distribution, this theory goes wrong, because now this is not in that 64.8 or 95.4 or 90. That assumption goes bad. That goes wrong, because when you calculate CPCPK or PPPK and you are estimating, okay, what is the 6 sigma? How many points are beyond the control limits? If it is a 6 sigma, ultimately we want to achieve our points in 6 sigma, right? So what should be the
99.9997%. Itself.
it is we typically call it as 3.4 ppm, right?
Yes,
3
sir.
that is 3.4. That means if you consider these 3 sigma, if you consider 4 sigma, 5 sigma on either side, ultimately you will find if you are getting a fantastic process of 6 sigma, you will find only if you produce 10 lakh parts, you are finding only 3.4 parts are on the either side of the will go outside the specification limit. So that is what is the typically call it as a 6 sigma process. All of you are with me, or you are finding it difficult? Because today we are going to discuss so many statistics. Okay, last week I told that. Okay, our tris, and that time I told that next week we are going to discuss statistics. So you should give me the same comment like that I told yesterday. Well, last week itself, right? Okay.
Yes, sir.
So
Yes.
yeah. So this you should stick to that. Okay, that was that was your commitment last week, right? Okay, so we are going to discuss a little bit statistics today. Okay, so if you have get stuck somewhere, please let me know, because now we should know, we should be thorough with that. Otherwise, it is just we will be showing it in a mini tab and will come with some conclusion. Okay, but before going for that kind of conclusion, we should be thorough with our fundamentals. Okay, base, right? Uh, so when you consider a normal data, this assumption of 60.8 or 95.4 or 99.73, everything will comes, right? And your estimation is based on that. Ultimately, what you are doing by CPCPK and PPPK. Okay, how many? If you are CPK 2 means what is the sigma? How many sigma you are CPK 2? What is your process capability if it is sigma is 2? CPK is 2. CPK 2 means what is the CPK 2? What do you mean by CPK 2? How much your process is in control? Or CPK is 1.67. What is the your control? How will you know?
99/3.
CPK 1.67. No. 99.73 when your CPK is 1. 99.73 when your CPK is 1. Right? Okay. That means CPK is 1 means how many sigma you are? You are at 3 sigma limit. When the CPK is 1 means you are at 3 sigma limit, 3 sigma level. Okay, your process is 3 sigma level. Now, how do you interpret a sigma CPK is 1 means what is the conclusion? What do you conclude by saying CPK is 1? The conclusion is that 99.73 points are percentage of points are within your control, within the specification. 0.27 is outside the specification. That means 0.27% you are outside. That in other words, you are having 2700 ppm. Okay, when your CPK is 1 means, and if you make 10 lakh parts, and you are coming to your CPK is 1 means, how many ppm you are meeting? How many? What is your ppm when the CPK is 1? It is 2700 ppm. Okay, that this is 3 sigma. When your process is capable to CPK 1, that means you are at a 3 sigma. Now, what is the speciality of 3 sigma? When you are process is 3 sigma level, you are bound to have 2700 ppm. Okay, when your CPK is 1.33, what is the conclusion? CPK is 1.33 means what is the meaning of that? Anybody knows what is the meaning of CPK 1.33? No idea. You multiplied by 3. You multiply it by 3. What is the if you multiply with 3, what is the value?
4 sigma.
4 sigma. Okay. So when your CPK is 1.33 means you are at 4 sigma process. Your capability is 4. Your CPK is 4 means you are running in a 4 sigma process, right? Now when the CPK is 1.61, what will be the number?
5 sigma. 5 sigma.
5 sigma, because you just multiplied by 3. 1.67 into 3, how much? Can anyone say? What is 1.67 into 3?
5.
5. 4.99. That means 5. So you are running in a 5 sigma limit. Okay. When your CPK is 2, what is the meaning? CPK 2. 6 sigma. Okay. So this is how you are correlating a process with reference to your CPK, right? You are at 6 sigma process, right? Now, what is the specialty of 6 sigma process? You are bound to have 3.4 ppm when you make 10 lakh parts. All of you are with me, or finding it is too difficult? Is it okay? Silence means shall I consider it as okay?
So 6
Okay,
sigma,
sir.
we are making 3 point.
6 sigma?
We make 3.4 parts. 3.4 parts.
3.5 parts per million. If you make 3.4, if you make 10 lakh parts, you are bound to have only 3.4 rejections, right? So that is the meaning of you are running at a 6 sigma process, right? Ultimately, the purpose of this 6 sigma process is what? 6 sigma, this black belt or master black belt, green belt. Ultimately, what you want to reduce the variation. You want to reduce the variation in such a way that if you make 10 lakh parts also, you are likely to have only 3.4 ppm, right? So that is the ultimate purpose. You have to reduce the process variation such a way that with reference to your specification limit, your process is so small that even though if you make 10 lakh parts also, you will bound to have only 3 rejection or 3.4 rejection. Okay, ultimately it is 6 sigma is what? CPK, 6 sigma, all this, what is the meaning of this one only, right? You are estimating capability of your process, right? Now how you estimating the capability? How you are you take a sample from a lot. Okay, you take a sample from a lot. Okay, and calculate with reference to that sample. You calculate your sigma standard deviation. Then you calculate CPCPK. And if you are getting your CPCPK 2, that means you are in a very good process. You are bound to have only 3.4 parts per million, if at all, if you make 10 lakh parts. So that is the ultimate purpose of process capability. Process capability, nothing but estimating a process with reference to estimating a process with reference to a sample from a lot and deciding the property of that lot. Okay, or estimating the property of that lot, right? So that is the purpose of calculating ultimately process capability is what? This is what we cannot 100% check. If you're getting 10,000 parts, you cannot check 10,000 parts. Okay, instead what you are doing, you are just collecting a sample from that, and using that sample, you are estimating that yes, this sample tells me that you are in a very good process with reference to specification, right? So here we are talking about two variations. One is the two things. One is that specification limit. Another one is our process variation, right? So with reference to specification, where you are standing, that is ultimately the purpose of process capability, right? Collecting the sample from a lot and estimating the capability. This is ultimately we are the purpose of CPCPK and PPPK. Well, okay. Now, so here only the problem is that if you don't have a normal data, your conclusions will go wrong. That is what is the meaning of this one. If your data is not normal, the defect area will be incorrectly estimated, and you will misrepresent the process sigma. Okay, that's what we are just talking in sigma, right? Okay, everybody is following me or finding it is too difficult? Am I going very high statistics uh, or limited statistics? I say I can because this is a master black belt program. That's why I'm going in little detail, right? Otherwise, you can just calculate CPCP and close it, right? Okay. Yes, everybody is following me or finding it too difficult?
Yeah, yes, following, sir.
Following, right?
Following, sir.
Okay, okay, fine, good.
Right.
Thank you. Okay, okay. So, since the data is not normal, your right side is different from left side. So, your this interpretation of what do you call 64.8 or 95.4 or 99.73 or 99.9997, all those things will go wrong if you have a non-normal data, right? So that is the purpose of this one, right? So there are some more uh, what do you call consequences, right? Process sigma calculation I already told you, right? Sometime now what will happen? Uh, the data may be normal, the data may be non-normal, but but distribution is wrong. But we'll sometimes will think that there are some special causes into it, but there is no special cause. There may not be any special cause. Okay, because the distribution itself is non-normal. We sometimes it is there are possibility that we conclude that it is a there are some special causes involved in the data, right? Then there may not be any special cause. The by nature, the innate process itself may be non-normal, right? Okay. And typically hypothesis testing, I hope everybody knows what is hypothesis testing, right? You know all what is hypothesis testing? What do you mean by hypothesis testing? Anyone knows? Two sample t tests, one way ANOVA, one sample t test. All those things tests are called hypothesis testing, right? You are right. Sorry, yeah, am I right? Hypothesis testing, everybody knows, nah?
Yes.
Okay. So hypothesis testing, uh, if the data is normal, not normal, yours sometime it may go wrong. Okay, your hypothesis may sometime you may tell null hypothesis as alternate or alternate hypothesis as null. Okay, so that can be a problem like that, right? Right. Okay. Next, regression. Right. Again, what is the condition of a regression? Regression, everybody knows regression, I think. Yesterday, no, we are not covered regression, right? Right. Okay, so regression also, what is the condition? Anybody knows what is the assumption of a regression? One of the assumptions of regression is that whatever error points, that should be normally distributed. Okay, what is the error point? With reference to the regression coefficient or that regression line. Okay, the slope. There will be the error. Okay. Anyway, we will be discussing multiple regression and all maybe in the next session. So we'll have more discussion on that, right? So one of the assumptions of regression is that the error points which should be normally distributed, right? Okay, it should be a homogeneous data, right? And the same thing is with the DOE also, right? So DOE, the purpose of DOE is that you want to do a prediction, right? Best process, right? So again, if the data is not normal, you will be coming into a wrong conclusion, right? Okay, poor predictive ability, right? So these are all some of the problems one may face, difficulties one may face if the data is not normal. Okay. Now, how do you know that data is normal or not normal? Okay, so don't assume that straight away. Don't assume that there are some special causes involved in your data. Okay, first of all, you can put a time order, okay, time series analysis, and see that any special trends or cyclical variation, those kind of things are there. Okay, that you have to first of all try it out, and you can stratify the data. Okay, you can stratify the data, and also you can see that whether any special causes are there. Okay, all those things you have to try out. Okay, we will do with one sample, you will have a more clarity. Okay, how to do time order, look for shifts and stratification, and look for some kind of skewness. All those things you can try we can really do some a real life example, and we can come to know, right? So before going into the data, uh, when you are collecting a data, first of all, what you have to do, you have to test for normality. Okay, if the data is not coming out normal, you should try some more things to see that whether any special causes are involved in that. Okay, if the special causes are there, then straight away it will be a non-normal data. So in that case, you may have to remove some other special points. Okay, out of control points. Okay, but it can so happen that data is don't have any data doesn't have any special causes, but still the data is skewed. Okay, so first of all, you have to try out all those things. Then after that, if you once you are confirming that there are no special causes involved in that, then you can think about transformation. Okay, so then with the current data, you have to transform to a normal data. Then you do whatever you want, capability, CP, CPK, PPK, all those you have to calculate, right? Okay. So this is what we are going to perform now, right? Okay. All of you are with me?
Yes, sir.
Okay, fine. Any question anybody having before moving into the real uh, action point, a real performance of performing one data, right? Okay. So here you can find, we'll do one case study to make it more clarity. Either it will give you more clarity or it will confuse you. Okay, that we will come to know at the end of the case study only. Will come to know, right? Okay. So what is the case study we have given here? So there is some data given here. Okay, some commercial lending business. Okay, collects data on time. Okay, so this is the data related to time to make a decision, right? Okay, so they have collected how many data? Their data points are there. 100 loan applications they have collected. Okay, and time is given in days, right? Okay. Now, what is the specification given here? Specification, by looking into this one, can anyone point out what is the specification?
Time.
Maximum 18 days.
18
18
days.
days.
Okay. So this commercial lending business, this organization considers anything above 18 days is out of specification. Means they are given a specification for this loan application. Okay. Within 18 days, they have to process their data, and they have to see that whether your process is capable. Okay. If all the data is coming within 18 days, then they consider it as a good process, because ultimately we are talking about on a specification limit, right? So specification limit is given, upper specification is given as 18 days. What is the lower specification here? Upper specification is given in the case study. So what is the lower
Can we
specification?
take,
0.
can we
Zero.
take 1 day? 0.
So here we are considering it as 0, right? If you want to put a 1, so that's also okay. But ultimately 0 is the better. The minimum is the better. Okay. So that is what is the case study, right? So here we are talking about one side limit. Okay, 18 days, right? Upper specification is 18 days. If you want to consider 1 day, that's also okay. 1 day you can consider as a lower limit, right? Okay. So this is what is we are going to do the test, right? Okay. Now, now let us go to our. Anybody wants to share their uh, mini tab, or shall I perform it in with somebody? People, when you want to do along with me, you can do along with me, or you want to share your mini tab screen. I will tell you how to do that, how to perform that. Whichever way you want, you can suggest. The choice is yours. Which way you want? You want me to perform, or you are going to do?
You can
Sir,
perform,
you
sir.
do, sir. Yeah, sir. We are simultaneously trying with our mini tabs.
Very good, very good. Okay, whenever you are getting stuck, okay, please tell me. I'll stop there and I'll tell you again. Right? Okay.
Sure.
So first of all, I'll show you that Excel sheet which I have shown you. Right? Uh, no, not this one. This is the normal data. Oh, I have not opened that. One second. One second. I'm just opening that. I had to, for sharing that I closed it. Right. One second. Give me a second. Non-normal data. Yeah. My Excel sheet is visible to all.
Yes,
Yes,
sir.
sir.
Excel sheet is visible, right? Okay, so the same case study, commercial business data take time to make the decision, and 100 loans are they are given the dates. Okay, 100 data points are given. Okay, 100 are there, right? And the specific time is given in days. Okay, some they are given 21 days, 30 days, 4, 8, 5. Some dates are given. Okay, days are given. Okay, and then we already know the specification limit. Okay, anything above 18, they consider it as uh, not meeting the specification, right? Okay, so this is what is the data available, right? Now, what you have to do, all of you, what you have to do, you have to just copy this area, this one, right? Okay, Control Alt Shift. Okay, and copy it and paste onto your mini tab, right? Now I am going to show it in our mini tab, right? Mini tab screen is visible to all. Yes, confirm.
Yes, sir.
Yes, sir.
Okay. So I suggest all of you to copy and paste on mini tab screen. Okay, and once you confirm it, just tell me, because you are going to perform it in parallel with me. Okay, simultaneously.
Done, sir.
Done,
Done?
sir. Perfect.
Okay.
Okay.
So, you ensure that that data is on the top. The titles are on the top of it, right? If you put it on side, what will happen? It will not consider it as a numerical data, right? You can see, um, you are
The
able to see
gray.
that the gray area, we don't put it, it will consider it as a text. Okay, this numerical will not be there, right? If you put it not put it on the that gray area, this will consider it as a text. Okay, these numbers will not be considered here. You see T. Okay, so here you cannot see that T, right? Here, because numbers are there, that T will not be there. Okay, that just ensure that, because some people who are not familiar with the Minitab, they make mistake this, right? Okay, so all of you are done like this. So you are finding only T on the decision and zone only, correct?
Yes,
Yes.
sir.
Yes. Okay, fine. Now what you have to do first, first of all, we will make a histogram, right? So can you make a histogram? How to do? Just go to graph and put on histogram, click on histogram, and do with the fit, right? You can just say yes, sir, so that I can also click. Then just say okay, and put the time. Okay, because our interest is not application number. Our interest is only time. Okay, so the histograms generally we cannot do it with discrete data. We can do only with numerical data, right? So the time is only numerical data available here. Okay, so you just say select. Okay, and just say okay. If you have got all those things, please let me know.
Got it, sir.
Got it? Who else is performing? They can also confirm me.
Yes.
Okay, fine. So you can see that typically this is looks like a normal or a non-normal.
Non-normal.
Normal, because you can see that
Q.
it is again positively skewed.
Yes, good.
Okay, so what is the meaning of this? So many data are there. So many data are there. that is very close to this one. But there are some data which is very dates are very long. Okay, days are long. Okay, few data are there that is very closely in this range. Okay, remaining all are on the skewed onto one side, right? So it has got a long tail, and one side is skewed like this, right? Okay, so this is confirming. We are confirming that it is a non-normal data. Okay, now this you can do by Anderson-Darling testing also. Okay, so this side is clear to all, right? Okay, now what you have to do? You have to perform a. I'm just just deleting this. Okay. Now next is that we have to perform a normality test. This is graphs. What generally do? Graphs gives you a apparent conclusion. Apparent conclusion means it looks like it is a non-normal. Okay, but we are not confirming this. How we are confirming? It is by visually it is okay. This is looks like it is not normal. Okay, but whether it is really not normal, how to do that? For that you have to do a normality test. Okay, you have to do a normality test. So how to do a normality test? Go to stat and basic statistics. Right? Everybody is with me? Okay.
Yes.
And go to normality test. So what is it is given here? Determine whether your data follow a normal distribution. Okay. So this is what is the purpose of this normality test, right? Okay. So click that on normality test. And which is the variable I have to consider? I have to consider this time, right? So
Right.
just click on time, double click. Okay, and there are some this one is a test of normality. Anderson-Darling, Ryan Joyner, Kolmogorov, Spinrov, all those things are given. But when we do in our normally statistical calculation, we consider Anderson-Darling only. Okay, so just click on that one. It is already inbuilt. Just say okay. Right? All of you got it?
Yes, sir.
Okay.
Yes, sir.
Now, okay. So normally, if it is normally distributed, what will happen? There is a line you are seeing. There is a line you are seeing. See, this data, all the data will be very close to this straight line. Okay, that is a speciality of a normal data. Okay. Now that is one method. By looking into itself, is it is away from the straight line, right? Okay. So this is typically this is not a non-normal data. And there is another method is that these all visually okay. But now look at the p value. Okay, what is the p value here?
Less than 0.005.
Less than 0.05. Okay, less than 0.005. Okay, so when you call it as a normal data, when your p value is when the p value is more than, what is the number? Anybody knows? 0.05. Okay, if the p value is more than 0.5, we call it as normal data. Okay, or we can call it as normally distributed data. All of you are with me? Not 0.05, we are talking about 0.5, 5%. Okay, more than 5%, we call it as normal distribution data, right? The p value is much less than even 0.005. This is definitely not a normal data. Okay, so this is how you can plot and you can test a normality of your data, right? Okay, so the first this one we have made a histogram, then we made a test. We have done a test for normality, and we concluded that this is not normal because the p value is not more than 0.5. The p value is less than 0.5, or it is given even less than 0.05. Okay, even 0.5%, less than 0.5%. So definitely this is not a normal data. All of you are with me?
Yes, sir.
Okay,
Yes,
fine.
sir.
Okay, now what do you have to do? now what you have to do is that we can do some kind of dot plot also. You can try that also. Dot plot just to see that how the data is distributed, right? Okay, just go to graph, and there is a dot plots is visible here. Graph dot plot is not there. Not visible.
Sir,
After histogram.
after histogram, sir.
After
After
histogram.
histogram.
Okay.
Yeah.
Right, dot plot is that. Now there is a width group, because now we have to consider all the data, time, decision, and zone. All the three we have to consider. So you put a width groups, right? Double click on that, right? And you time you put it on the graph value, and categorically you put it as a decision and zone. Okay, so what this is going to do, this time, if with reference to decision and with reference to zone, this will show you how it is distributed. Okay, so that is what is the purpose of this dot plot. Okay, just say okay. Right, now all of you done this?
Yes, sir.
Got like this?
Yes.
Yes.
Okay.
Yes.
Okay.
Yes,
Got it?
sir.
Okay. Now what you do? You see that this data is also now like our histogram only. So many points are here. Then this like this. So many points are. So here it is approved and not rejected. Both data it is collected, and it is collected for 4 zones: east, north, south, and west. And rejected also east, north, south, and west. So you can see that based on this data, this is showing that again like our histogram. Some points are on the close, other things are on like dots it has come on the right side. Okay, so this is also kind of positively skewed only. Okay, so this is also like showing that some idea, okay, how it is with reference to we have done a dot plot with reference to your categorical variable like approved or rejected for 4 zones, right? So this is showing another this one, right? Okay,
Sir,
now
this also based on p value, it is showing
no, this is a
0.05%.
graph. This is a graph only. This is it
No,
will
sir,
be
it
a
is. My
uh,
doubt is it is approving, rejecting something. No, we have not given the specification limit here. That
no,
whatever we have discussed, but it is
huh.
showing it is approved, not rejected. How, in what basis it is taking rejected, sir?
No, rejected was this your categorical data. Yeah, anything above 18 it is considered rejected. Anything below 18 it is considered as approved.
Yeah, understood, sir. But we have whether we have given the data, key in the data 18, it's upper specification
No.
limit.
We are not given. We are not given. We are not given. They have rejected for some other reason. Okay, they have
Okay,
approved
that's why,
rejected
sir.
for some other reason. For other reason. This
Okay.
is not
And
at given.
what basis this graph is telling us after this data all these are rejected? In what basis it is taking, sir?
No. This
How it
loan
is
application,
approved?
some loan application they approved. Some loan application they are taken a decision on that. Some loan
Oh,
application
okay,
they are
okay.
rejected. No, they are not taken decision. Their decision. Okay, approved or rejected. Maybe some reason is for approval, some reason for rejection. Okay, it is not based on days. It is whenever you apply for loan. Sometimes this loan that no the what do you call, your papers are okay, then they call it as approved. If the papers are not okay, then it is rejected. You may have to submit some more data, right? Okay, or some basis for loan application, when you sometimes they reject, sometimes approve, right? For they have their own criteria for that. Okay, here we are doing that decision whether it will come in within 18 days or it is not coming in 18 days. That is our ultimate purpose of process capability. Their decision. Okay, this loan application, how much time they took for a decision, right? Approved or rejected, how much time they have taken. That is what we are going to study here. Okay,
Understood.
we are not thinking that why it is rejected or why it is approved. Even you can see that 3 days also they are rejected. Okay, because they are not met certain criteria, that is why they are rejected. So that area we are not covering, right?
Okay,
Clear,
sir.
na?
Since it is in the since it is in the data, it is showing like this, right, sir?
Yes.
Yeah.
Okay. Right. Okay. So that side is also clear, right? Okay. Good question, right? Okay. Now that is also over. Now we have to try time series. Okay. What is the purpose of time series? To know that whether you are having any cyclical variations, right? Okay, some kind of cyclical variations are there that you want to try. Okay, so for that you have to do a time series analysis, right? So just go that stat basic statistics. Is there any time series? No. There's a time series you can see here. In the statistics itself, there is a time series.
Yes,
Yes.
sir.
So just click on time series plot. Right? And symbol one we will take it. Just say OK. And click on time. Right? Okay. And just say OK. So what you are finding here? You are finding a time series. Okay. Now the data you can find here, there is no special trend or going up or going down or some cycles. Nothing is there. It's all randomly distributed here and there. Okay. So just by looking into time series, we are just concluding that okay, this is not there is no special cause or something like that. It goes up or down or a cyclical variation. That nothing is there. It's all distributed in a randomly here and there. Right. Okay. So that is the purpose of time series. Right. Okay. Just to this all like when you are going for a test for your doctor, they'll ask you to test something, na? Then only you will be ready for so like that. If you have got some doubt that your data is having some special causes, you can do all this kind of tests. If you are very sure with your data is not normal, you can straight away go for a transformation, right? Here what we are doing here, just to we are confirming that it is not having any special causes, right? So that is what we are confirming with all these graphs and all, right? Okay, now we can go for I hope everybody got it, right? Now it is time to go for our transformation, right? Now before going transformation, we can just see that you can, there is a one more thing. You can go for quality tools and there is an individual distribution identification. All of you are seeing this quality tools? Yes?
Yes, sir.
Okay. Double click on that.
Stat quality individual distribution.
Stat quality tools, individual distribution transformation, right? Okay.
Yes.
Just click time, right? And subgroup wise, you just write as what? Okay. All of you done this?
Yes.
Done? Okay. So now just say okay. Now what it has done, this data, na, it has made a lot of different kind of distributions. What is the purpose of that? To just to confirm that any of the distribution is following this data is following some distribution, right? Okay, so all of you have got it, this one.
Yes.
Okay, yeah, so you can see that Johnson transformation, it is 0.68, right? What is the meaning of that? If you do Johnson transformation, your p value will be more than 0.05. Okay, now you can find that there is some logistics also 0.0 more than 0.05. Otherwise logistics you can see it is less than 0.05. And 3D logistic, nothing is there. Okay, so much loss. Okay, now if you see smallest extreme value, again this is less than 0.1. Largest extreme value, gamma, 3D parameter, none of them are this is not following anyone. Okay, now you can see variable distribution, 2 parameter exponential, this one all you find, this all less than 0.5, right? Okay, now you can see here box cost transformation, you are finding 0.299. Okay, so this can be box cost transformation possible, log normal possible, and Johnson transformation possible. Okay, because this is all the values you find, you are finding that p value is more than 0.5. Okay, so these are all ready for I mean this is suitable for this kind of transformation. Okay, or this is you can do with that this kind of transformation, because this is not a normal data, it follows some other kind of data, right? Okay, clear? Okay, now since it is eligible for box Cox and Johnson transformation, we'll just see, transform it and see that how it is happening, right? Okay, ready? All of you got it, this one?
Yeah, please wait, sir. I'll make note.
Okay.
The quality tools.
You are going to start quality tools and individual data distribution. Okay, this the purpose of this one is just to confirm that whether you are what is this is what is possible with your current data. Okay, so it is giving you some recommendation. So using that recommendation, we are going to perform that. Right, that is the purpose of this. Just to see that how it is the data is distributed. Right. Okay.
Yes, sir.
Done? Okay.
Yeah.
Okay. So Shobita is doing this one. Nah? Who is doing this one? Somebody is doing, nah? Yeah.
Yes.
You are also doing. So somebody is confirming. Everybody got it? Okay. Shakti also. Right. Okay. So done. All of you are confirming? Yes. Okay. Shakti, you want to ask something? It's okay, nah?
Okay, sir. I have done.
All of you have done this? At least some of you. Shakti, Manoj confirmed. Anybody else?
Sir, I
Done, nah?
have done it. Yeah.
Okay. Okay. Now, since it is both the transformation is possible, just try with those transformation and we'll come to a conclusion, right? Okay. So first we will try box cost transformation, right? For that, what you have to do? You just write box cost. Okay, because I have to transform this data to box cost and see that. Okay, whether it is normally distributed, right? So just write one column, any column. You could put it as give a title as box cost. Okay, or a B transform, anything you want, you can give. Okay, we want to just confirm that it is transforming. Okay, please B transform or box cost, anything you do, right? Okay, then okay, now go to stat control charts. There is a box cost transformation visible here. Yes.
Yes. Yes.
Okay. Just click once again stat control charts box cost transformation. Okay. Just time. Just say subgroup size as 1. Okay. Now I want to transform it to what data where I want to transform it to B transform. Okay. I have given that is the name. Okay. You can give any name. Okay. Okay. And say okay. Okay. So the data is transformed here. Right? Right? It is transformed here.
Yes.
Everybody got it? Got it, na? Yes?
Yes, sir.
Okay. Right. Okay. Now, you have to just remember one number. What is this number?
Right. I got the graph, but I'm not able to get this and the data points in the tab actually. Can you tell me how should I pick it?
Data point in that column. Huh?
Yeah, in that column C7. I'm
So,
not
do one thing. Go to stat,
yeah.
control charts, box cost transformation. Then go to option.
Okay.
In that, where to transform that column name you give here.
Okay.
Okay. I'm clicking here. Okay. So it will go and sit there. Right. Okay. Now just remember this value. Rounded off value 0. Okay. This number is very important. Okay. This value we have to think. What is the value? 0.00. Okay. Just remember this number. Okay. Done. Yes. Okay. Now do one thing. Now this has come. Now we have to just test that whether this is now transformed into the new value. Okay. Now it is transformed to a new value. Okay. Now just test that whether this value is normally distributed. So go to normality test and B transform. I have transformed, right? And J say okay. Now what is the P value?
0.299.
Okay. What is our criteria?
Greater than 0.05.
5%. It is coming as a so this has become a normally distributed data. Okay. Now this is eligible for our capability study. Okay, capability study remains same. Okay, I'll just show you how to do that. Go to stat. Everybody is with me, na? Okay, stat. Go to quality tools.
Sir, previous
Okay.
step once again, sir. Sorry, previous step.
Normality test. Stat, basic statistics. Go to normality test. Okay. Normality test. Then now not time. Time is already we have seen that it is not the normal distributor. Now we have to transform the data we have tried. So not transform data I tried. Okay. Now I got more than 0.05, right? Okay.
Okay.
Okay. So this is what is the transform data has become normal. Okay. So this I tested. Okay. Now I am eligible for box force transformation, right? To go to stat, quality tools, and capability analysis. Okay. Go to normal, right? Normal. Now this same data, time we have to consider. Okay. Time, subgroup size 1. This much is done. Everyone done?
Stat quality tools.
1 second, I'll go to stat, quality tools,
Capability.
analysis, normal.
Okay.
Okay, just select time. Okay, and subgroup size is 1, and our specification is 18, right? So upper specification is 18. Okay, now here itself we have to transform. Okay, go to transform. Now box cost transformation. Okay, now what is our lambda value? We got it. I told you to remember one number, na?
0.0.
0, right? So just go to click 0. Okay, just say okay and okay. Okay, you got your value. Right now, what you got it is calculated based on your transformer data. Okay, now your prediction is okay. CPK is 0.31. Right? It gives you PP, PPK, CP, GPK, all those things. Right? All of you got it? Okay, fine.
Yes.
Yes.
There's a big silence, so I think.
Yes, sir.
Got it, sir.
Okay. Okay, na? Shakti is okay. Others are also okay, na?
Understood. Yes.
Okay, na? There is a silence.
Okay, sir.
Sir,
Okay.
box cost, I have missed it, sir.
Yeah. Told me.
It was coming error for me, sir. Can you do it again for box cost?
The error is coming because you want to show your screen. Can you show your screen?
Just now I have deleted that. Again,
Oh.
I'm planning doing it, sir.
Again, you are doing, okay.
Yeah.
So, oh my God. You want to show the Minitab screen? You want to share it or shall I show? If you are done, please tell me.
You can, yes, sir. You can show, sir. I will also do it.
Okay. So,
Simultaneously.
yeah, stat, control charts. And this one is you got it or this one also you are not got?
This one I have not get it, sir. It's because of error.
Okay, fine. Control charts, box cost transformation. Done?
Yes, sir. Yes.
Time you click it. And subgroup size 1. That also done?
Yes, sir. I did a mistake in subgroup size.
Okay,
Now I understand.
Now options, go to option and go to that B transform, click it. Click it.
Yes, sir.
Okay, now you say okay, what is happening? Coming, all right. Getting or not getting?
Yes, sir. Yes, sir. I got it,
Ah,
sir.
okay.
Thank you, sir.
Okay, now go to basic statistics normality test it. Okay. You're doing it. Basic statistics normality, and double click on B transform and just test it whether it is a normally distributed. Okay, are you getting
Okay.
0.29? Got it? Okay. Now go to do one thing once again. Go to stat quality tools. You just say yes, sir, so that I can proceed further. Done?
Okay, sir. Yeah, yeah. Done.
Go to normal.
Okay.
Click the time.
Okay, sir.
Subgroup 1.
Okay.
Then transform. So in that box cost we are done, we have seen that a lambda value, which was a
Lambda
0
zero.
showing there. Okay. Whatever number
Ah.
comes that you have to do it, right? If it is coming 0.5, you have to say 0.5 or some other value between -5 to 5, you have to put that number here. Okay. But in our case,
Okay.
since we got 0, you click on 0. Okay. Just say okay and
Yes.
okay, you will get it. Okay. You got it, this one?
Yes, sir. Yes. Thank you,
Okay.
sir.
Okay, fine. Now, so we are clear with the box cost transformation, right? Okay. Now, only thing, just remember that box cost transformation has got some one limitation. What is the limitation? Is that if the number is minus, B transform will not happen. So, in that case, you have to either transform to, like, if you have got a value like 2, okay. If I want to make it this one, you can write this as 2 plus 2 is 4, na? Like that, if it is 3, 2 plus 5. Okay, these also transformation only. Okay, what is the linear transformation? 2 plus 2, 4, 3 plus 2, 5, 5 plus, if you got 5, you can transform it as 7, right? Okay, like that, if you get some negative value, you can transform it like this. Okay, if you are, that is one method. Otherwise, now we have got one more method that is called, generally, if you have got a negative value in this, in your data, box cost transformation, there is a limitation. It will not consider. Okay, so in that case, we can go for a Johnson transformation, right? Okay, so we'll see Johnson transformation now, right? Okay, ready for Johnson transformation?
Yes.
Okay, so we
Yes,
will
sir.
go for that. Okay, 1 second. Data got stuck. Okay, fine. Now we will go for Johnson transformation, right? Okay, Johnson transformation also go to stat. You make a column called J transform. J transform, right? Then go to stat, quality tools. There is a Johnson transformation visible.
Yes.
Okay, just click on Johnson transformation, right? Then click time, right? And you want to confirm it to JS transform, right? So just put it on JS transform, right? And just say okay.
I'm not getting the J transform column there in that. How should
I'm
I?
also not getting the stat.
That quality
Basics.
tools,
Qual-
Johnson transformation, click it.
Ah,
You already made J transform, one column name title you gave us J transform.
Yes, sir. I've given that, but I'm still not able to get that.
You are not able to see here.
Yeah, in the selection column, I'm not able to select the transformation. Yeah.
Not able to select that.
Okay, okay, got it.
Got it now? Okay. Okay, fine. Now got it?
Yes. But
Now here,
values, how will I pick it up? So value will have to be picked up. The value is not picked up in a table actually.
which value?
In the mini tab below, I'm not able to see the value.
The column.
The
Same
column.
here, sir.
Column?
I got the graph, but I'm not able to see the numbers in the mini tab.
Transform. Yeah.
So here it is
The
not coming.
data. Yeah.
It is
Yeah.
not transformed.
Yeah, it's not getting transformed.
Yes, sir.
I don't know
So
why it
the
is not.
So the J transform value where you are taking?
J transform has happened now.
sir,
Here
please.
J transform value has come. Value has come. In my case, it has come.
Sir, could you please repeat this? Close this and again.
Okay. Right. Stat,
Okay.
quality tools,
Okay.
J transformation. Okay. Click the time.
Okay.
Okay. Now, where you want to transform this? I want to transform in a column. The name of that column I gave it as J transformation. Okay. I am putting as J transformation, right? Okay. Or you can put it anywhere. C7, C8, any number you can give. Okay. Since I have given a name, I am putting that column. Okay. Double click.
Now,
So it has come here.
now I
Now,
got it. Now I got it.
now say okay. So it has to come here.
Yes, sir. Yes. Got
Got
it.
it? Got it?
Yes, got it.
It has come, right? Okay. Maybe you might have done some mistake. Okay.
So
Everybody got it?
initially only 3 columns are coming. So he got confused.
Okay. Okay. Now, what is the p-value here?
0.68.
0.60.
68. 66 or 68, whatever. Okay, more than 0.5. Okay, your non-normal data, it is as usual, it is 0.05, below 0.05. But transformed data, you got it 0.68. Okay, got it, nah?
Yes, sir.
All of you got it?
Yes. Sir.
Yes.
All of you can control. Anybody got stuck anywhere? No, nah?
Yeah, good.
Okay. Okay. All are so far good, right? Okay. So if it's done, then we'll go for our transformation and we'll finish it, right? Okay. So here I don't have to check for a normality because already it is given normality. See, previous case we had done a normality test because that graph was not showing the normality value. But in this case, you are getting a normality value. Okay, 0.68 already given here. Okay, fine. Now what you have to do? Go to stat, same method. Stat, quality tools, capability analysis, normal, everything same. Everything remains same. Right? Just go to transform. In this case, you have to go for a Johnson transformation. And if you want to put a p-value more than 0.5, you convert it as 0.05. Okay? Done?
Please wait, sir. Start.
Already stuck, I'll repeat that. Okay? Stat, quality tools, Johnson transformation. Click here.
Sorry, hello.
Start with body.
You take same, right? Okay. Go to options. Sorry. 1 second. Go to all of you gone to options. Yes or no? Capability analysis normal. Okay. Go to transform. Click on Johnson transformation. You can 0.1 you can convert into 0.05 because our 0.5 is p value, right? Okay, just say p value is 0.5. Okay, and remaining all same. Time 118 all same. Okay, just say okay. Now here we will not get a CPK. Johnson transformation will give you only PPK value. Okay, so that is you are getting 0.3. Okay, and the box cost transformation also you got the same value. 0.3 only. You can see that verify that graph. Okay, stat, quality tools, capability analysis, normal, transform, box cost transformation. Also, I am getting the same value. Okay. Here also I am getting 0.3 box cost transformation. Also Johnson transformation also getting the same value 0.3, right? Okay. So this is how you can perform transform the data and you can do the normality test. Okay, you can do the your remaining capability analysis, right? Okay. I hope everybody understood, have a basic idea how to do this, right? Okay.
Okay.
right?
Yes, sir.
Okay,
Yes,
so
sir.
that is the, got it? All of you got it, nah?
Yes, sir.
Yeah, that's all. Our work is over. Right? Simple. Right? So this is what is the purpose of. So this is slightly different from what we learned in our black belt. Is some additional, what do you call, additional study, advance of our.
Transformation.
Okay.
Okay.
In fact, we are done in some of our master black belt 1 year or 2 year back. Somebody had a similar. He was working in bank or something. So he had a data. So that data had a similar problem. Okay, they had this non-normal. Okay, then when he has done his project, he has transformed into J transform or something. B transform, J transform, something he has done, and he had done his study. Okay, so generally, in the manufacturing industry, generally we expect a normal data, but especially service industry, when the data is coming like bank queue, if you see all this area, you will find this kind of people find this kind of difficulties, and then they will do this kind of transformation and do the study, right? Okay, so this is what is ultimately we are we are
Sir,
done. Ah,
what is the purpose of using this J transfer instead of histogram, sir? That is also showing the same way, no?
not
What
not
is the
getting
purpose? No,
purpose
sir.
of
What is the use? Yeah, use of this J transfer, sir. We are able to get in this graph in the histogram itself, no?
hmm. Here
Yeah.
you can see the difference is that you can see that after doing the Johnson transformation or this one, you see the graphs condition, you see the graph condition. Oh no, sorry, 1 second. The graph is now normally distributed. Okay, we have done a transform. Na? So the previous case we have not got it, right?
Yeah.
See, the data has become it was like a skewed like this, and now it has become a normal. See, after doing transformation, the data has become a
Yeah.
normal distribution. Okay, so that is, see, non-normal data, we are
Yeah.
converting into a normal data. Then we are performing the
Okay.
study. Okay, so a non-normal data has become normal now. So that is the purpose of transformation. So ultimately, that is the purpose of this class itself. A normal data transformation will transform it. Okay, so that is the what is the purpose of this? Clear?
Yes, sir. In theory, we are changing, sir. Practically, when you
Yeah.
measure it, if it is abnormal data, as you said, if we are changing it in a theory, how it will be useful for our practical purpose, sir? Maybe I'm confusing, sir.
Okay. So I don't know whether I'm able to answer your question correctly. See, in theory, we got this data. This is the theory we have got it, right? This time.
Yes, sir. Yes.
Okay.
Yeah.
Now this data, with reference with using this data, if you do a CPCPK study, you will get some result.
Yes, sir.
You will, but that result may not be perfectly all right because it is not a symmetrical. It is not a normal data. It is a non-normal data. Okay, it's just skewed
Yeah.
to one side. Okay,
Yeah.
so when you are coming across that kind of situation, what you have to do is that you have to convert into a normal distribution and you perform this CP, CPK or PPPK study. Then you will get your results will be more accurate. Okay, your predictions will be better. With the transformation, you will have a better accuracy. Result will be predictability is better. That is the purpose of a transformation. Non-normal data, because it is not symmetrical on the either side, your conclusion will not be correct. Okay, still you can perform it, but then your data may not be, your prediction may not be correct. So in that case, what you have to do, you have to transform it and do the same study. So that is the, see, ultimately what we are doing, you are doing performing a transformation. Now, what do you mean by a transformation? What is the meaning of transformation? Transformation means, see, log value.
Yes,
Log,
sir.
what is log 10? What is the value of 10 for log? It is 1. Okay. If it is log
Yeah.
value of 100, it is 2 because 10 raised to 2 is 100, right? Log value of 1000,
Yeah.
it is 3. Okay.
Yeah.
Right? Na? 10 raised to 3 is
Yeah.
1000. See, this is no, your value going like this, but this value na, you see, this is not 1, 2, 3 only, but this value is na, it is 10, 100, and 1000. So I have transformed this, but this value is changing. The value, these changes are not that much. Okay, this kind of transformation actually we are doing here.
Okay,
Okay,
okay, sir.
okay, that see, I am not doing anything with this data. Okay, I am converting this data into log shape. Okay, when you are converting to log shape, I am getting like this.
Okay.
Okay, so I am not doing any changes in that data. Changes data means you have to change the data 5, 6, 7, all that you have to change. That I am not doing. With the present data, I am converting into some kind of log. Okay, so that is what I am doing in log transformation. Right?
Okay, sir.
You can, you got it,
Using
na?
this J transfer, using this J transfer, how practically I have to apply, sir? That's my question, sir. You have that you got the data. Practically, you have taken some data and continuous data, and you are using for transferring to B transfer and J transfer.
Why? What is the reason?
In
What is the
what
reason?
basis?
What is the reason for transforming? What is the reason for transforming? Because it is not a normal data.
We couldn't
The
measure.
data is not normal.
We couldn't
That is
measure.
why I am huh?
Couldn't measure the capability earlier. After
Ah.
transforming, we were able to measure the capability.
Capability, but the prediction will be better because it is a now it is your it is meeting all the your normality curve properties. You are getting it. That is the purpose.
See, our
Sir,
CP,
my
our
connection got disconnected. Sorry.
madam, our CPCPK calculations are based on normal distribution. Do you agree?
Yes, sir. Yes, sir.
CP equal to USL minus LSL divided by 6 sigma. Where what is 6 sigma? Spread of
6
your bell
sigma.
curve.
Yeah,
But
bell
right
curve.
now the spread is not symmetrical.
Yes,
So
sir.
in
Yes,
this
sir.
condition, using the formula will give you a misleading CPCPK. That is clear, right?
Understood, sir. Yeah, yeah. Clear.
So for the same situation, if I have got normal data, then my
Okay.
CPCPK will be more realistic. You agree?
Agree, sir. Agree.
Now, either you should have a perfectly normal data or you
Okay,
should
sir.
not use bell curve method right now. If you don't want to use
Oh,
bell curve method, go to some other curve.
okay,
Like there
okay.
are many other distribution, isn't it? One thing
Yes, sir.
is you find out the equivalent distribution. Look at your curve.
Yeah.
And I think
Okay.
Vinod Shankar sir has taught to identify
Mm.
which model fits now.
Okay, sir.
Whether it
Okay.
is bell curve, bell distribution, or some other distribution. Once you
Okay.
find out the right distribution, then you
Okay.
can use the formula applicable to that distribution. That
Okay, sir.
Minita
Okay.
will do it. But
Okay.
that is one method. There is alternate method. Imagine I run a company, in India, and I get all my payments, from my US client, and the payments are in US dollars.
Okay.
If you look at my Excel sheet, everything is in US dollars, but my people don't understand.
Yeah.
You know what will I do? I will convert
We have to
all
convert it in
dollars
INR.
into rupees. Then my people
Yes,
will
yes.
understand how much business I am doing, what is my sales in lakhs and crores, and everything my people will understand. But
Okay, sir.
again, my US client want the same detail. Then what will I do? Again, I convert the rupees into dollars and send it to them.
Okay. Yes, sir.
Same data, one set of people in US, they are getting in dollars. Another set of
Yeah.
people in India, they are getting in rupees. What is the
Okay.
transformation formula used? $1 equal to
It's
Conversion
85
rate.
rupees.
yeah, conversion rate. Yeah.
In
The same
dollars
thing.
also, your answer is correct. In rupees also, your answer is correct.
Yes, sir. Yes.
Correct?
Yeah, yeah.
Same manner, right now my data is not normal, so I am not
Yeah.
allowed to use the normal distribution formula.
Oh,
If
okay.
I do something and convert my data into a properly, normally distributed data, it will enable me to use the same formula again. Yes or no?
Yes, sir. Yes, yes.
So you do whatever you want. For converting dollars into rupees, you multiply it by 85.
Yes, sir.
Now, for converting a non-normal data into normal data, a person named Johnson, he did an extensive research.
Oh, okay. Okay.
And through his research, he found a formula for transforming a non-normal data into a normal data,
Okay.
right? And that formula you may have to search what exactly is the formula. Maybe like Shankaran sir was explaining, there is log also involved. According to the logarithmic transformation, log of 100 is 2, log of 1000 is 3,
3.
log of 10,000 is 4. Like how $1 is equal to 85 rupees, log of 10,000 is equal to 4. Do you understand? So
Yes, sir. Understand.
I will transform each of my data with the transformation formula suggested by Johnson. Now I have a new set of data. This new set of data, if I visualize through a histogram, I will see a smooth distribution again. That means now my data is ready for CPCPK using the same method. Do you understand? Now my CPCPK value will be more realistic. Now my CPCPK value will be more realistic. Clear? So my data is transformed and CPCPK is obtained. After obtaining the CPCPK, what will I do? I will transform the CPCPK again using the same formula I used for transforming the data. Do you understand? Dollars converted into rupees. Again, rupees converted into dollars. Yes or no?
Dollar. Yes, sir. Vice versa.
So for the original data, I want the CPCPK value. So I transformed the data, converted into normal distribution. And then for the transformed data, CPCPK value is converted. And finally, that CPCPK is mapped into my original data.
Okay.
So you really don't have to understand each of the step that is happening behind, because he might have done research for a longer period, and then he has come out and that is agreed. So you can also trust Johnson's transformation formula, what he found, and that is helping you to convert any non-normal data into normal data.
Understand.
Clear?
It's work. Basically, it is working on the formula. Invented by Mr. Johnson, right, sir?
Yes. If you use formula, it will convert a non-normal data into a normal data.
Okay, sir. Okay.
And that also you can check. After transforming, you can check whether it is normal or not. If it has come normal, then you use it. Use your original formulas and find out the CPCPK. And finally, that calculated CPCPK also should be transformed back to match your original data.
Okay, sir. Understood, sir.
Okay,
So that's
one
how it
second.
is, right?
I'll just show one just for since she has asked.
Okay.
Just just see, we have got some data like three there, na? So I'm just transforming this right into log normal. Okay, so ln 3. What is the value? 1.098. You are able to see my screen sheet? Screen visible?
Yes, sir.
Shobhita, you can just check your mini tab. The box cost transformation. What is the value for 3?
Okay, sir.
Just check and tell me. What is the box cost? You got it, or shall I show?
Sir, you can show, sir, so that.
Okay. I'll just show you. I'll just show you since you asked this question. Where is that? Many tab screen corner. So many files open.
Sir, but during the transformation, the upper specification limit is also got transformed from 18 to
Yeah. Everything that Minitab will do that calculation. You can see that on side of that you can see that all the transformed value also they are given. Okay, 1 second. Where is so many files are open? 1 second. 1 second. This is not you. Okay. Okay. See the value 3. Just remember the value 3. What is the value?
1.098.
98. Not just write somewhere. And for 5, what is the value?
1.609.
609. Na? Now I'm just show how it is transformed here. No, not this one. No, this. The minute app. 1 second. Okay, I'll just show in one Excel sheet. Right. Okay. Right. Okay. What is the value for a 3? What you have written?
1.098.
So
Same
same
thing, sir.
0.98 you can see here.
Yeah.
This is ln ln equal to 3. Okay. This formula given ln I am putting as 3. Okay. So I got 1.098. Okay. What is the value for 5?
1.609 only, sir, in that also.
Your point 1.609.
Yes, sir. Yes, sir. I
Okay,
got it,
so
sir.
this log, it is just the same 5. It is converted into a new value. Like GSK sir was telling, converting dollar into rupees. But that is a linear transformation. But it is a log normal transformation. That is the only difference. Okay, this transformation is not linear. It's a logarithmic transformation. Okay, any value you can take it. 5 is means you just say ln 5. You will no. What is the value? 7 or 7, any number 7. So you will get that 1.94. If you check your box cost transformation, you will get the same result. Okay. So just it is converting that into a log normal. Okay. That's what it is doing. Right. Okay. So that is how the transformation happens. Okay. But that is Minitab doing itself. So that is why, we don't have to do all these things. If you are doing in Excel, you may have to do individually like this. Okay. That is the difference. Right. Okay. So this is a transformation. Oh, since you asked, I'm just showing you how the transformation happening. Right? Okay. I
Okay,
hope.
sir. Thank you, sir.
Okay, fine.
So what we learned is whenever data is non-normal, it is better to believe the formulas given by Johnson transformation, as well as the sequence of steps carried out by Minitab. It will do everything that is required. Like Sakti Manoj was correctly asking, sir, when we transform the data, do we have to transform the specification limits as well? Yes. If you move from X to Y, then you have to move everything from X to Y. Finally, for reporting your answer, you have to move back your Y to X again. That's how this is what your Minitab is doing. It will do everything that is required and give you a more realistic CPCPK value. Otherwise, you might end up calculating a misleading CPCPK value. What is the use? It will be value much better than calculating the CPCPK directly using a non-normal data. More realistic. See, statistics is only prediction. It will take you as close as possible to a realistic situation. So that will happen to the best level if you follow these methods. Oh, okay, right. So I think Shankaran sir has explained the concept very well. Maybe you may have to practice and maybe take one or two real-time data which from your own process, and then you will be able to better understand. If you actually run a company and deal with an US client as well as a Singapore client, you will understand all the calculations that is happening, isn't it? You calculate in a particular way for Singapore dollar and then some other way for US dollar and back and forth, everything you will do perfectly the same manner. You will understand if you deal with some real time data from your process, or maybe practicing the exercise multiple times can certainly help you to understand. So there could be an assignment on this because the topic seems to be very interesting. So we'll help you with one assignment and you all can do it, and also try to write the interpretation after the analysis is obtained from Minitab. Write your understanding about it, what happened, and so what is the conclusion, something like that. That will definitely set things right. Okay, thank you very much.
So there is one more sheet, Excel sheet. There is one more file, that Excel sheet. There also you can just try it out yourself. Okay, there are two files I have given, two case studies. You can see in that Excel sheet. One we have performed, one you can do in homework. And if you are finding any difficulty, please let me know. Okay, next time. Right?
Okay, sir.
Okay then. Thank you very
All
much.
right.
Have a good dinner and come back. Okay.
Thank you, sir. You too, sir.
Okay.
Thank you, sir.
Bye.
So please
Okay,
come by
sir.
9 o'clock, sharp 9 o'clock. All of you, please come back. We'll discuss
Sure, sir.
something.
Sir, recording you may have to pause.
I'll pass. I'll pass.
Fine. See you next time. Bye.
Bye, sir.
Next week.
Sir, the Excel